Hello, everyone. Welcome to another SETI Live. I am your host, Beth Johnson. This is going to be our last SETI Live for the year, so we're excited to do one more for you all. And happy winter solstice for those of you in the Northern Hemisphere and summer solstice for those of you in the Southern. So yeah, days are changing length. Oh my gosh. All right. As 2021 wraps up, we have invited SETI scientist Seth Shostak and astrobiologist Nathalie Cabrol to discuss some of the most exciting developments from the past year and what might be in store for 2022. This is also our annual fundraiser. So if you think that the search for life beyond Earth is important, please make a gift before the end of the year. We will have links in our show notes on the bottom and also in the chat for you to follow. So we really do appreciate you. And I will make sure that I shout out people. Please let us know where you're watching from. We will shout that out as well. So let's get things started. Hello, Seth. Hello, Nathalie. Don't forget to unmute.
Yeah, hi. And Seth is still muted.
Working on it. Working on it.
Yeah, well, there we go. It's because of all the emails I have from people who say, you're better muted.
So guys, how was 2021 for you? It was kind of a year, I think, for a lot of us that we don't really want to talk too much about in depth, but scientifically, Nathalie, what happened for you this last year?
Well, scientifically for me, as an astrobiologist, so wearing the hat of the researcher, not the director of the Carl Sagan here, I would say, well, I got stranded. I cannot go to the field. This is unacceptable. I just cannot go to my mountains. I cannot climb. I cannot dive. So this has to stop. People get vaccinated, get boosted. We want to get out of here. Do something. So basically, I had to, do like everybody else, get seated in my office or at home. And think about things. And it was a great time actually to do a synthesis of, all the discoveries that are happening. And so a lot of things are exciting. So for me, it's been writing a lot, thinking a lot, putting together a strategic vision for the Institute for Science for the 5 coming years. So, bittersweet. The bitter aspect is, well, I'm home and stranded. But the good thing is that I hope that there is a vision coming out of it.
Oh, that's good to hear. I can't wait to hear about the vision. Seth, how about you? How was this last year for you?
Well, it was a mixed bag, of course, Beth. I mean, I had a couple of months in which I had my office and I was working from the office. And that had the big advantage that I was farther from the refrigerator. So in some ways, I was more productive. I think that in terms of the science and SETI in the past year, the thing that struck me the most is the fact that SETI is broadening. Now, any of us who are working close to the refrigerator are probably broadening. But what I mean by that is that there are more organizations doing it, more people doing it, and the approaches are wider than has been the case for the past, 60 years, right? Where we kept looking for radio signals. We're doing that. We're doing it better than ever. But there are also other approaches that, in the past couldn't have been done. And I think that that's a good thing.
So what is one of the approaches that you're thinking of from this past year that's come about?
Well, there's a group that's it's headed by a woman astronomer in Sweden, Villaroel, and I'm sure I'm managing her last name. I think Nathalie could really do that. But in any case, she has done some interesting experiments where she compares the night sky in photographs from telescopes with the photographs of the same part of the night sky that were made maybe 30, 40 years ago, right? You'd think, it's not going to change much. Stars don't move that fast across the sky. It's all going to look the same. And it does, mostly. But there are some things that seem to have changed. Some stars that seem to appear, others that disappear. And after you rule out, natural explanations like supernovae and all that sort of thing, you're left with a small handful of objects that seem to be doing something that isn't natural. And of course, for SETI, that's an interesting result.
That sounds really interesting. I want to talk to you more about it. I want to give a shout out to some people watching, just a few so far, coming in from Colorado, and then Brazil and Canada. So welcome, bonjour. And also thank you, Zach, over on Twitch for the 100 bits. Very appreciated. Nathalie, you published a book this year, en français. Can you tell us what your book was about and what you covered?
So yeah, and we are looking for English publishers, so hopefully soon to come to the bookstores around here. It was an invitation from a publishing company in France. It's an autobiography, but it covers as well. So the personal journey and the scientific journey covers the Mars exploration, Spirit, Gusev, obviously a big adventure on Mars, what it took to get Gusev selected, and the many years we spent then roving with Spirit and Opportunity at the surface of Mars. And at the same time, in parallel, the beginning of a journey in the Andes, looking for extreme environment and terrestrial analogs to Mars, especially since we knew by then that Mars was habitable, early Mars was habitable for life as we knew it. I wanted to understand what kind of life was there in those terrestrial analog and what kind of instrument we would need to find it on Mars. And so that started a 15-year journey, still ongoing, in the Atacama, the Andes, and the Altiplano, where we deploy instruments, we deploy rovers, and we're simulating missions. Also talking about my journey as, and the more recent one, as the director of the Carl Sagan Center, and a wonderful adventure that it is to share the scientific broadening, as Seth was saying, of the Institute, which is doing very, very well. I would also like to add to what you were saying for Seth and the SETI search, is that not only so the SETI search is broadening worldwide, but it's also now broadening at the Institute itself. It's been making great progress in the past year or so, something we can all be proud of, and give some kudos to Andrew Simeon, who's directing the SETI search here at the Institute. So wonderful news there.
That's also fantastic. So Nathalie, what advances in astrobiology have you seen this last year?
Well, you know, astrobiology is such a broad field, but obviously, you know, because I've been looking closely at what's going on Mars, of course, the landing of Perseverance in Jezero, followed by Zhurong, the Chinese rover. And so what that says to me is a couple of things. The first one is that planetary and space exploration, there too, is broadening to keep going on that theme, where you have a number of space agencies who have an integrated program and have had one for many years, who are going on Mars and transitioning from the characterization of habitability to the search for life. So Perseverance is a biosignature detection mission. And so right now we are looking for traces of past and present life. And there has been recently an announcement 2 days ago about organic molecules being found at Jezero Crater. Again, you know, organic molecules are just like Lego bricks. These are the bricks of life. It's nothing until they are being assembled. But it's very important that we keep confirming that they are there. It means that they are abundant, and this is a good news. So you have NASA and ESA. ESA is coming up next in 2022 with the launch of Rosalind Franklin, the rover, and then Zhurong, and also the Indian and Emirate mission were showing that more countries are getting involved. So to me, that's the Mars size. In terms of astrobiology, you have this incredible mixed bags of little things like a meteorite, a chondrite that was found and fell in the UK, and happens to be one of the oldest rocks that we've ever found, pristine, from the very, very, very beginning of the solar system. So a lot of information coming from there. In terms of sustainability of life, the DART mission that just launched to not intercept, but see how we do in trying to modify the trajectory of something that's threatening life on Earth. And we can talk more about a number of things, but something that is really important to me is for people to understand that the Earth is a planet too. You know, we talk about planetary exploration, but we rarely have enough frame of mind to consider life on Earth and the environment as part of a planetary process. And seeing what's going on with global warming, environmental change, which is directly the astrobiological message of coevolution of life and its environment that we are so, there's so much looking for on another planet. We have it here and we are messing it around and seeing the temperature not being, a little higher, but just pulverizing record with storms and with heat, high pressure sitting on countries for days and days and days. This is a big signal that it's really, really time to do something. But there are good things too. I'm sorry, I'm going to stop here.
That sounds like okay. Let's take a moment. I'm going to give a few more shout outs to people who are watching. We've had people check in now from England, more from Canada, Australia, Pennsylvania, Norway, and Virginia. So welcome everybody. Thank you for watching. I'm going to switch from Nathalie back to Seth for a minute. Seth, sure. You're also you've kind of started on another project this last year that got announced, right? You're now a member of the Galileo Project.
Oh yes. I was trying to think what project have I neglected here?
Will you tell us a little bit about that project and what that seeks to do?
Yes, Galileo is the idea and the project actually of a Harvard astronomer, Avi Loeb. Many of you may know about Avi Loeb. He's in the papers a lot. A couple of years ago, when this object, the Oumuamua, which is, that's only its first name. The middle name is a little difficult, but Oumuamua was zipping through the solar system. It was seen as a dot. And the question was, what is that thing? Because its orbit proved that it, or at least indicated that it came from another solar system. So what was it? Was it a comet? Was it an asteroid? Avi Loeb suggested it was something that was artificially constructed, an artifact. Okay. And that would be, of course, incredibly interesting if true. It's still not clear whether it's true. Most astronomers who study asteroids think it's an asteroid. But in any case, Avi Loeb got interested in the whole UFO, or as they're now called, UAP story that came out of it was a front page on the New York Times in 2017. But it, had to do with the release of these or leak of these Navy videos showing strange peanut-shaped objects zipping around. And so he has started this Galileo project because he's very interested in things that might be in our atmosphere, that might be sailing over your head every night and you're unaware. So I am part of the Science Council for that.
And how is that project going to work? What observations are they planning to take? How are they collecting the data?
Well, they are going to build their own equipment, which is an interesting approach. And so they're going to have cameras that, the intention, ordinary cameras, some in the infrared, but mostly in the visible, that would have enough resolution and enough focal length of the lens to actually see whether some object has, UQU constellation or something, some name on the side, USS Enterprise, for example. If they were to see some Klingon script on the side of these objects, then you would say, I don't think that that's an asteroid. So that's one thing. It's a visual reconnaissance, but they're also going to look in the radio. They're going to even have audio. So if it makes a strange sound, there'll be that. And they're going to build their own hardware. They've got some money. They're not going to rely on anybody else's hardware.
Okay, so that's something we can definitely look forward to in the next year, hearing more about that project.
Yeah.
Go ahead.
No. I didn't mean to interrupt you.
So Nathalie, tell me more about ExoMars, about Rosalind Franklin, about what the expectation is for that particular mission going forward.
Yeah. So the first expectation, I guess, just like the James Webb Telescope, would be for that thing to launch,
and the parachutes to work, right? That's where the parachutes
we are
are
all
the
crossing our
concern.
fingers at this point in time. It is so close, but at least it's on the launch pad, which Rosalind Franklin is not yet, but they are making progress towards this. And they were delayed. This was precaution and delayed due to COVID, obviously. But Rosalind Franklin has very similar objectives compared to the Perseverance rover. The thing that it has that's a little different has a longer drill, which means, and this may be very, very critical, because we have been running numbers for a number of years about how the top layer of the surface of Mars might be affected by cosmic rays and short UV radiation in terms of how it destroys whatever organic material that could be in there. So there are discussions about is this a few centimeters, is this a few meters, etc. So the longer drill that might be able to get to 2 meters would be first the deepest drill we ever accomplished on Mars, and might give us access to material that has been preserved and not being altered by interaction with cosmic rays and UV radiation. So, excuse me. The other thing is that landing in Oxia Planum, which is the landing site for this mission, it will be on one of the best exposure, rock exposure and layers of the planet. And there are lots of clays in that area. So clays are really important for a number of reasons. The first one that, well, they seem to indicate that Mars was wetter and a little warmer in the past, although you can make clays many different ways, okay? And clays are also very important when you look at some of the theories of the origins of life. So great landing site. Some people say that the origin of life, it's the RNA world. Some others are looking at different things. And some models say, well, it's a clay world, because a clay is something that would act really as a foundation for organic molecule and has some interesting properties that makes it really a key mineral to go and look at. So I am really looking forward to that mission as well.
I am too, and I hope that the parachute testing continues to go well, and that we get through COVID and we can finally see that one launched too. A couple more shout outs, more people watching from Brazil and the United Kingdom, and someone is now watching from Illinois. So great, welcome. Once again, this is SETI Live, and we are the SETI Institute. We are a nonprofit organization. This is our last SETI Live of the year. And we're hoping that you guys can give a little bit more as we go into the holiday season and help us keep our outreach and education programs going. If you like our content and these shows that we produce, please show your support. We've got a link in our various chats that you can click on, and also your stars, your bits, your subs, and your super chats on all of our various streaming platforms also help. So thank you, everybody. Seth, you were talking about broadening the field of SETI. What else is on your mind when it comes to broadening? What else is coming up? What else have we seen in this last year?
Well, we've seen certainly an improvement in existing SETI projects, in particular, the Institute's own Allen Telescope Array, which is up there in the Cascade Mountains of California, which was declared a restaurant-free zone many years ago. You can't get anything to eat there unless you either hunt it or bring it. But we have our telescopes up there that have gotten new receivers, and beyond that, they're all working. We're well on the way to get almost every one of them functioning again. And that's a great thing, because if it doesn't work, you won't find the aliens. There's that. But in terms of other things that are happening in SETI that involve the Institute, there's also this cosmic project. And that's kind of an international thing. It's being done by many people. But the idea is to use the Very Large Array, which is down in New Mexico, right? 27 antennas spread out over 11 miles of fairly dry real estate. That instrument is being used 24/7 by astronomers to do radio astronomy research. But you could do exactly what's done with the particle accelerators. You just take off, if you will, a beam. You just split some of the data stream and send most of it to, or half of it, whatever it is. You send all of it, actually, it's just a copy. You send all of it to the radio astronomy computers, and they analyze whatever they're interested in. But the other copy of it goes into a SETI system that can sort of point at different places where there are nearby stars on the sky, as this thing is doing. So it's a matter of simultaneously doing SETI and radio astronomy. And the big advantage of that is, you don't get to choose where you're going to point, but you can, always find nearby stars to point at. And the other thing is that thing is running all the time. So you cover an enormous amount of the sky.
I'm waiting for that one too. I feel like we're just in this point of waiting for so many things right now. We spent all year waiting for Perseverance to land and then to collect its first rock samples. And now we're waiting for that telescope to launch any maybe day now, hopefully. Nathalie, with the world closed down, I know you're missing your field research terribly. Where would you go right now? Would you go back to Chile? Would you go back up to the Atacama and go back to doing research up there if you could go anywhere at the moment?
Yes, I would. There are obviously other places, but the reason why I keep going there is because it's not only a terrestrial analog for one thing. Sometimes you go to Iceland or you go to other places because you want to see how life does in this type of pH or in relationship with the ice. Here, it's an environmental analog, which means that you have the geology, you have the thin atmosphere, you have the high UV, you have a number of things. So there are so many questions, especially in terms of biosignature detection, that we need to still tackle at this point in time. And one of the advances with our team this year, the NAI, was to start showing that there are patterns in distribution of extreme life. And so how much we can learn from that to try to figure out how to detect life on Mars is something that I want to pursue. And I will definitely go back there, especially because it is so difficult to, at this point in time, we don't have a definition for life. Period. So this is one thing. So it's really hard to search for something you don't have a real good definition for. But then, at least trying to detect what we know. Because look, if there is something that has been making a lot of noise this year, is really the phosphine detection on Venus. And so that goes back to the same question of biosignature detection. Not only we don't have a good definition for life, but actually at this point in time, we don't have any real biosignature that is unique to life. Hence, the whole discussion about phosphine. I am one of those who really don't think that this is related to life, but, and I have a number of reasons for that. But what is good about phosphine is the same process that happened with the so-called fossils in the Mars meteorite, for instance, or the PR experiment in the Viking mission. These are things we are confronted with, and then we have to decide where they lie, living and non-living. And so we might not have the answer, but the process of asking those questions is really what gets us closer, first to build the right instrument to detect those things. And second, also to try and understand what is there a real biosignature that we need to look around. So these are the kind of things why, field experiment, lab experiment are very important to astrobiology. I still personally lean towards the field because it throws at you a number of things that are not, as sterile as what happens in the lab. But the lab is important to actually isolate some processes. Okay, I shut up.
No, it's all interesting. Okay, so I'm gonna give a few more shout outs. We're now viewers from Pakistan, Utah, and Germany. Willkommen. We're talking with Seth Shostak, senior astronomer here at the SETI Institute, and Nathalie Cabrol, the director for the Carl Sagan Center. And we're talking about what the last year has been like for SETI research, astrobiology research, and what we're hoping for in 2022. So we're kind of wrapping up towards the end of the half hour here. Seth, what is on your radar for next year?
Yes, no radar allowed because that creates interference. Well, again, I think that the things that got started this year will continue into next year, but also will bear fruit, which I'm always in favor of, and vegetables. The things that are happening at the Allen Telescope Array are, pretty darn exciting. I mean, getting all the telescopes working, but more than that, we're developing new receivers. These actually had been developed a number of years ago, but they were very finicky, and now they're being fixed in a way that makes them, as they say, robust. And to the extent that anybody can be robust under these conditions where you work indoors all day. So that's proceeding apace. And keep in mind, the Allen Telescope Array is our telescope. So we can use it 24/7 to look at those things that we think are most interested in terms of possibly hearing from ET. But as I said at the beginning, what are the difficulties with what's known as signal SETI or electromagnetic radiation SETI, if you like, a lot of Greek, is that you're pointing your antenna somewhere on the sky, and in order to win the Nobel Prize, you have to hope that the aliens have sent a signal that will arrive at your antenna just when you're spending a little bit of time to look in their direction. And that's, that might not be terribly likely. Who knows? Whereas if you say, look, I'm not going to forget all those third grade, low level aliens, only look for the most advanced ones, because the most advanced ones could easily be billions of years more advanced. The universe is that old. Then maybe the thing to do is look for something that they've done. They've restructured the local universe where they are. Maybe they build a Dyson sphere. Who knows? But that's something else that SETI can do and will start to do simply because of improved equipment.
So one thing I want to ask you about before I cut back to Nathalie, Seth, is we just announced today that our laser SETI in Hawaii is up and running. What does that do? What does that entail? How has that changed what we're doing searching wise?
Well, it's simply to say, in addition to looking for radio signals, we look for flashing lasers in the sky, right? And you might think, well, that sounds nutty, but it's not nutty. It turns out, look, we invented the laser, 60 years ago, something like that. And we even have the capability of building a laser, a big super duper laser, like they have in Livermore, California here, not terribly far from where we are. And you aim that at a mirror that's maybe 10 feet to 10 meters across, say, and that's not so hard either. You could build that. And aim it at a nearby star system, and for a billionth of a second, it will outshine the sun, okay, from their point of view. And so if we can do this now, think what civilization a million years in advance of us could do. And so it could be that the sky is filled with communications channels that are all based on lasers. And that's what this new laser SETI will look for. It's not the only optical SETI experiment, by the way. There's several others, and they're all pretty good, and they're all pretty exciting.
Hey, I was really excited to send that press release out today. So I'm glad. I'm glad that we're getting to actually share that with everybody else. So Nathalie, how about you? What did you enjoy this past year, and what are you looking forward to next year in as far as your research or just the astrobiology field in general goes?
Yeah, we talked about what I thought was important last year and that I enjoyed. I think that it is important for the field now to keep building in biosignature detection, technosignature detection. This is really what we are, which will force us to think more about, what is life and about biosignature and technosignatures. So what I enjoyed at the end of the year was a publication by one of the former SETI PI, Chris Campes, about multiple life, multiple path, saying that life is going to use absolutely whatever it can to be there. So there might not be only one origin of life on Earth. There might be several origins of life on Earth, and we cannot recognize it because although the letter of its alphabet might be the same, it might not be in the same order, and our tests are not designed to find it. So this is, to me, this is really exciting because it gives some space to the shadow biosphere, which is a little bit of the same thing, which is that, life could have appeared several times on Earth and be so different that we cannot recognize it. This is very important to us to pursue those ideas, whether they are right or wrong, just because by doing so, we are getting some clues on how to look for life beyond Earth, life that could be different. But I'd like also to end by saying that there was something that I'm really looking forward for 2022, and that was outstanding by its absence in 2021. Remember how in the previous year, there was not one day without an announcement with big headlines about the discovery of exoplanet?
Yes.
It is really below the radar here, and Seth will be happy, no radar here, and I think this is outstanding because it means that it is so common today that it seems that journalists don't think it's, novel enough that they need to spend a few lines on that, which means that we are discovering them by the wheelbarrow. There are more planets than stars in the universe, and that says a lot about the search for life beyond Earth. It's a statistical game. And so for me, this is something I'm really looking forward next year, because we are bringing the James Webb, crossing fingers again, to that quest. And this is going to change absolutely everything, because now we are going to be able to see smaller objects, and we are going to be able to start poking into their atmospheres too.
To your point, I have been very excited by the fact that as a journalist myself, the exoplanet releases have ceased to be, oh, look, we've found another exoplanet, but rather, oh my gosh, you have to see this weird exoplanet that we found. And it's always these strange outlying unusual cases now. And now that we're applying machine learning algorithms to discovering exoplanets, we're getting them in batches of hundreds instead of 2 or 3. So yeah, it is a huge advance. I'm about to have a friend. Hold on. Would you? Thank you. Are you gonna? No? You're being helpful. There's an ear. Do either of you have any last remarks as we wrap up today and head into our winter break? Seth?
Last remarks. No, only this. Science, like 10 or 15% of the population has a really hard interest in science. They like to read stories about science. So that's obviously a minority. It's been 10 or 15% since the Second World War. That hasn't changed very much. But in fact, I think it's worth reflecting on the circumstance that this is the first generation. You listening today, you're a member of the first generation that has the technology, the knowledge, and of course, the wherewithal and the interest to actually find out if we're alone in the universe or not. And I think that's a pretty exciting subject to talk about.
And Nathalie?
Yes, I couldn't agree more. And there are a number of other things that we can add. We are the first generation that's capable of seeing its own planet from above. And that change of perspective is really something that is our legacy. But what I would like to close with is really how proud I am of the group of scientists that we have at the SETI Institute, and the work that they have been doing, throughout this year and the previous year of COVID, keeping the mission, the vision and the mission in check. And so also the amazing awards that they have been receiving, the level of the awards that are prestigious awards in the field that they are working on. So the SETI Institute is multidisciplinary, going from origins of life to ET and the search for advanced extraterrestrial civilization. And it's made of exceptional scientists doing exceptional science. So think of us and keep coming because you are going to be amazed by the work that they are doing.
And to that end, thank you, Nathalie. Thank you, everybody, for watching. Thank you to Sabine for your donation of stars today. We really do appreciate the gift. Once again, SETI research, in particular, the search for intelligent life beyond Earth, has extremely limited government funding. So it's supporters like you who keep it going, who keep us going, and who also allow us to do all of this outreach and present SETI Lives to you nearly every week of the year, sometimes multiple times a week, depending on what's going on. And we love being here. We love talking to all of you and sharing all of our science. Thank you to Seth and to Nathalie for joining me this afternoon. And I wish everybody a happy holiday season to those who celebrate, and stay warm and dry no matter where you are. And take care of yourselves and each other.
Happy holidays.